Okay, so scholars, today we're going to discuss the spectral emissions lab. So we just did the lab during our last class, and today we're going to go through the lab report. And what I've noticed is that for the semester, a lot of us haven't been turning in our lab reports. So that's unfortunate because the lab reports are really straightforward, and getting a good grade on a lab report is just really a matter of going through the questions and answering them. And so we're having more and more lectures to go through the questions in class so that we all understand how to answer them in our lab reports, okay? So you're literally going to have, after the end of today's lecture, a video on Google Classroom that you'll be able to watch. And if you watch the video, you can go through point by point and write your lab report in case I move too fast for anybody, because I know a lot of us are still getting comfortable with English, right? And a lot of us are still getting comfortable with laboratory reports. So here we go, right? We're going to go through this whole thing together in class. Additionally, the lecture that we had last class will help us with this class's assignment, which is to complete the lab report. So I'm just going to kill the lights because they're a little funny. So, okay, so the first order of business is this. The guiding questions that are listed below are not to be included in the lab report, okay? So don't use numbering for your guiding question answers. So your lab will receive a grade of 0 if the questions are included in the lab, or if the lab would not make sense to a reader who is unfamiliar with the questions, okay? So as always, this lab report has to be written in paragraph format, not just in bullet points or answers to the questions. And you have to really include a phrasing of the question in your answer to the question. So, for instance, in the introduction, the first question is, what is the visible light spectrum? You don't want to just say something like a continuous spectrum of light between the wavelengths of approximately 430 and 750 nanometers, right? You wouldn't want to say that. You want to describe what it is. So the visible light spectrum is an array of, a continuous array of light frequencies that spans the distance between 420 roughly and then 750 nanometers. And I don't know the exact boundaries. You'll want to look those up, okay? But those are approximately correct. And I Google them whenever I need them. So you'll want to answer that question, right? This is one for you to look up. And then how does the entire or continuous spectrum of visible spectrum differ from band spectra that we observed in the lab, right? But you're going to get to the lab later. So what you want to do up front is just say that this continuous spectrum of light, which we can see in the rainbow, is different from band spectra, which consist of just individual bands of color. Okay, so band spectra don't contain every single wavelength of light within a certain span. They only contain certain wavelengths here and there, like we saw in our lab last time. And why do atoms emit band spectra? Okay, so we discussed this in our lecture last time, but just briefly, atoms emit band spectra because excited electrons can only exist in certain energy levels, and so they can only transition to certain lower linear energy levels once they're excited. Therefore, the frequency or the wavelengths of light that they release correspond only to those energy differences, okay? So really, the short answer to this is because electrons only exist at discrete energy levels, okay? And we covered that in detail during our last lecture. And how did we study spectral emissions? Well, our materials and methods take us through what we did, but a quick summary of this would be to say that we studied spectral emissions by observing and recording the band spectra of several different chemicals, okay? As well as sunlight. We looked at the spectrum of sunlight, which was continuous. All right, materials and methods are here. So remember, this is like the freebie point that you get in your lab. So you can just copy this straight over into your lab report, and you can get your point there, okay? That's 10% of your lab just for copying and pasting, and that's fine, because that's what scientists do. They don't really have to think a lot about materials and methods. Sometimes they just literally write, see so-and-so's paper from 1985 or whenever the paper was done. Okay, results. So this is pretty simple too, right? You've got your results table in your notebook, and you're going to include that for step 2 here. But for step 1, what you want to do is describe what you actually saw during the experiment. So you completed an experiment, and you saw different things, right? And so you want to write about what you saw and describe what you saw. So when you looked at sunlight, what did you see? What did you see when you looked at sunlight through the optical diffractometer?
Rainbow.
Saw the whole rainbow, right? So just like you would see on a rainy day with some sun somewhere, right? We saw a whole rainbow in our optical diffractometer. And did we see a rainbow when we looked at the little cathode ray tubes? Did we see full rainbows when we looked at the cathode ray tubes through our optical diffractometers? Is that what we saw, whole rainbows? No, Yardley's shaking her head. No, what did we see?
Like specific colors, but not
Right,
exactly.
right. And we can call those what kind of spectra? Continuous spectra or band spectra? Band spectra, right? Just individual bands of color, okay? So that's what you'll talk about. You'll just talk about the difference, what you observed under the different circumstances, right, with the different sources of light, okay? So you talk about what you saw, and then you go ahead and define what you saw in your table, okay? And you can really just use the table that you have in your notebook, but don't take a picture of it with your phone. Go ahead and insert a nice table using Google Docs, okay? So you go to Insert Table. Last bit of business. So, do your results indicate that excited atoms produce band spectra or continuous spectra, and how do you know? Okay, so which one? Continuous spectra or band spectra from excited atoms? Which one do we have? Ben, do you remember?
Band spectrum?
Band spectrum. Good. Okay. The sunlight produced a continuous spectrum. The atoms produced band spectra, right? And how do we know? Well, we know because we measured with what? What did we use to do our measurement? What was that little pizza slice thing called?
An optical diffractometer?
Yeah, that's your optical diffractometer. That's exactly right, okay? And so what do our results allow us to conclude about electrons within atoms? So I'll simplify that question, right? Do electrons exist in any old energy levels within atoms, or can they only exist at discrete energy levels? Discrete energy levels, okay? Electrons can only exist at certain energy levels. So that word discrete, it just means specific, okay? Only certain levels are possible, all right? So remember, right? I can stand on the floor, I can stand on the chair, I can stand on the table, right? I can't stand right here, like in between the table and the chair. Can't do it, okay? Only certain heights are possible for me in this system, okay? Floor, chair, table. And electrons are really in a similar situation within atoms. They can only exist at certain energy levels. All right. So if we have any questions, I'll address them shortly. Otherwise, this lecture and the previous lecture should contain all the information that you need to write a full credit lab report, okay? And that's what I want for everybody. I want everybody to write a really nice lab report and to just start getting into the feel of what that's like, okay, as a scientist. So, that's all for right now.